So let's have an example of batch costing. AB Limited is committed to supply 24,000 bearings per annum to CD Limited. So this is the supplier, this is the customer, and this is what they are to supply. So on a steady basis, it is estimated that it costs 10 USD as inventory holding cost per bearing. So the inventory holding cost is 10 USD per bearing per month, and the setup cost per run of bearing manufacture is that is the setup cost. Then they're asking us what would be the optimum run size for bearing manufacture. Optimum run size is also known as the economic batch quantity. Yeah, so optimum, it's like the economic quantity. So it is the same as this. What would be the optimum run size for bearing manufacture? Then what is the minimum inventory holding cost at optimum run size? The minimum inventory holding cost at this. Then, assuming that the company has a policy of manufacturing 6,000 bearing per run, how much extra cost would the company be incurring as compared to the optimum run suggested in A? So this is our question. So let's have the solution. So we are going to start with A. What is the optimum run size? So we said optimum run size is the economic batch quantity, and the formula for economic batch quantity is 2AS out of C, like that, whereby this is the annual demand, the setup cost, then the carrying cost. Carrying cost is the same as the inventory holding cost. So here, like in the question, they have told us they are committed to supply 24,000 bearings per annum. So this is the annual demand. So the annual demand is 24,000. Then it is estimated that it costs 10 USD as inventory holding. That is the carrying cost. So they told us the carrying cost is 10 USD, but they said it is per month, and this one has to be carrying cost per annum. So we shall get $10 times 12. What we get is going to be 120. $120, but it is supposed to be in percentage. So 120 divided by 100, what you get is 1.2. So the setup cost, is 324. So we are going to substitute in there. So it is 2AS out of C, whereby it is 2 times A is 2, like that, times S, which is 324, out of 1.2, like that. So 2 times 24,000 times 324 divided by 1.2, like that. So we are going to square it, so it will be like square the answer. That's what we have. So our economic batch quantity is 3,600, like that. So that is the economic batch quantity. It's what they asked for here. What would be the optimum run size for the bearing manufacture? So it is this: 3,600 bearings. Then what is the minimum inventory holding cost at the optimum run size? So here they want the minimum inventory holding cost. So we get this minimum inventory holding cost. So we shall get average inventory times carrying cost per unit. Carrying cost per unit. So average inventory, we shall get this, we divide by 2. Divide by 2, then times the carrying cost per unit. It was this one. This was just the percentage, but this is the carrying cost per unit. So it is 120. So this will be 3,600 divided by 2, then times 120. That is it. So it is 21600. So that is the minimum inventory holding cost at the economic batch quantity you get. Yeah, average inventory times the carrying cost per unit. So that is it. Then part 3. Part 3 says assuming the company has a policy of manufacturing 6,000 bearings per run, how much extra cost would the company be incurring as compared to the optimum run suggested in A? So if the company is manufacturing this instead of the 24,000, how much extra cost would they be incurring? So here we are going to have a cost statement, something like that. So we shall have, we shall have a statement showing total cost at production run sizes we have the production run size of 3,600, the one we got, and then the one of 6,000. Yeah, so we are supposed to compare the cost because they have asked us how much extra cost would the company be incurring as compared to this one. So we start with the annual requirements. Annual requirements. Annual requirements for the first one, it's the same thing, 24,000. Then they give us in the question the annual demand, 24,000, like that. Then the run size, the economic batch quantity. For the first one we had this. Then for the second one they've given us the 6,000, so it's what we put here. Then the number of runs. So this one we shall get this divide by this. So we name this A, we name this B. So this one will be A divide by B. So this out of this. So this one will be 24,000 divided by 3,600. $6.667. So 6.667. Then we do the same thing for the other 24,000 divided by 6,000. It will be 4. So that is 4. Then we go to the setup. Setup cost per run. Setup cost per run was given in the question. This one, it remains the same. So this is 324. This is 324. Then we go to the total setup cost. So the total setup cost, we name this one C, then this one will, we name this one C, then this one will be D. So total setup cost, it will be C times D. So C times D, which is this times this. So it's going to be this times this, 324. Here we have 1,296. Then here we are going to have 6.667 times 324. That is it, 2,160. Like that. Then we are going to have the average inventory. Average inventory, this is our inventory. So we are going to have B, this B divided by 2. So this divided by 2, it is 18. Like that, 1,800. Then this, it will be 3,000. Like that. Then we shall have the carrying cost. Carrying cost per unit. Carrying cost per unit, it is we had gotten it, it was 1 point, that one, the one we had gotten at first, this. Then we get the total cost, total carrying cost. So this was our D, this was our E, this was our F. Then this is the G, this is the H. So total carrying cost will be F times G. So this times this, it's going to be F times G. So it is 1,800 times 1.2, which is 2,160. Then this will be 3,000 times 1.2. it is 3,600, like that. Then after that we get the total cost. So the total cost, we are going to add the setup cost plus the carrying cost. So it's going to be 2,160 this plus this plus 2,160. So for this, it is going to be 4,320. Then for this, we get the setup cost plus the carrying cost. So it is 1,296 plus 3,600, like that. So it is 4,896, like that. So the question was, how much more is the company going to incur if the rand size is 6,000 and not this? So we are going to get a difference between this and this, and that will be the extra cost that will be incurred. So that minus 4,320, like that. So the extra cost will be USD 576, like that. So for batch quantity, for batch costing, you must be able to understand the economic batch quantity, the formula, and how it works. Then you must be able to know how to calculate for the setup cost and then the carrying cost. Yeah, you just play around with these, the annual demand, the setup cost, and then the carrying cost. Once you learn that, yeah, batch costing will be so easy for you. So thanks for watching. Hope you've gotten something from this video. Let's catch up in my next video.